friends and students, welcome to today's session on Power Screws Part 1. Learning objectives of the today's session. After thorough study of this session, you will able to explain power screw, multiple threaded screw, types of threads and terminology of power screw. After this session, you will able to calculate torque required to lift and lower the loads for square threaded screw, and you will able to understand the concept of self-locking and its importance in power screw design. These are the objectives of today's session. Let us see what do you mean by power screw. Power screw you will find in many applications. Look at this first figure. It's a screw jack. You have seen in automobile or vehicles to take out for maintenance purposes to take out the wheels. Screw jacks are used to lift or lower the loads for that vehicles. Second one is the C clamp. Third one is the puncture machine. Again the body is having the nature which is the like a C, and then Y is to hold the workpiece here. The here screws are used, here also the screw, here also the screw, and in this case also the screw. All these are some of the applications we have already seen or used in our day-to-day life. So what do you mean by power screw? Power screw means it's a mechanical device which is used to convert angular or rotary motion into linear motion. That means by giving the rotation to the screw, so you will get here linear motion. It's the main purpose of the power screw, and along with this transmit the power. That's why power screw means mechanical device which is used to convert rotary or angular motion into linear and transmitting power. Again you will find it produces linear motion for machines where linear motions is required in different applications or in machine tools. Again it is also used. Then main purpose is to convert in some of the cases linear motion to rotary motions also to exert the necessary force. Then again it is also used to transmit the axial force also, and use in main application I have already told, use in screw jack, lead screw, vice, universal testing machines, or for different application. In case of sluice gates also power screws are used. These are the some of the applications: screw jack, C clamp, then puncture machine, vice. You will find many application. You can visit our workshops, even though you might have using four-wheeler, the screw jacks or toggle jacks. You will find the power screws are used. Then vices or bench vices. Then C clamp to hold the the workpiece in case of for drilling purposes or other purposes also. Here in case of puncture machine, again to hold the tube to, it's a traditional way to do the the puncture of the tubes in case of vehicles. But again to hold it properly, it's a heater. Again this screw is used again for the vices to hold the workpiece for the cutting and other the operations also. These are some of the applications. In this topic we are going to learn some of the the basic terms or terminology related to the power screw. But through this unit what we are going to learn, we have to design such a power screws for different application. That is the main objective of this unit. Advantages. So what are the advantages of power screw? So you will find large power transmitting capacity. Large power transmitting capacity, it is one of the major advantage. Then second one is you will find this design is very simple, only three components. One is the screw, second one is the nut, third one is the body which is used to hold the nut or a screw. Then easy manufacturing, well simple components, that's why easy manufacturing and compact one. Then you will find large mechanical advantage you will get through manual operation. Large mechanical advantage means, take the example of screw jack. Now to lift the vehicle for maintenance or other purposes, by giving the putting a small effort, you will get the more, we can lift the maximum weight, and that is the large mechanical advantage. That means load of 15 kilonewton can be raised by applying the effort of 400 newton. Why 400? That the human being can put that effort. That's why through this 400 newton we can lift 15 kilonewton load. That's why it's large mechanical advantage. Then second, it's a smooth one, noiseless operation, and accurate motion. Accurate motion in case of machine tools or lathe machine, you will find the lead screw which is used for a accurate. In some of the the operations of the thread cuttings and other automatic operation, we are using this lead screw here. That means to obtain the accurate motion. Then self-locking property. Self-locking property means to prevent its movement downward direction without putting some efforts or a force on a. In case of screw jack, you will find when you are going to lift that vehicle, during that time no need to put a hand on the Tommy bar, even though you will find the jack remain in its position. That is self-locking property of the screw. All these are the important, you can say the major advantages of the power screw. But power screw is also having some limitations and disadvantages. Efficiency of power screw is low as 40%. And because of this minimum, that means towards the lower side is a 40, you will find it's more than 40 also, 50, 60 also, but poor efficiency. And because of that, you will find they are not used in continuous power transmission application, except the machine tool operation in case of lead, that is the lead screw. But in other screw jack, we are not continuously using the screw jack. As and when required, we are using it. Likewise, other the C-clamp, bench vices and other devices are also used as per our the requirement. This is the limitation because of this poor efficiency. Then second one is the high friction. Here high friction in nut and that is screw. You will find it causes wear of the screw and the nut. Third one is the square thread nut is made of softer material for easy replacement. Why softer material? Because of this high friction, there may be possibility of wear. That's why possibility of wear, we have to replace the screw or the nut. But nut replacement is easy, cheaper one. It's not a costlier asset. And then you will find, and to avoid this the wear, the trapezoidal threads in case of the lathe, that is split nut is used to minimize the wear. That means some the provisions are made to how to prevent or how to reduce the wear, but wear is the disadvantage of the power screw. Try to understand. Then applications where these power screws are used. From these advantages and limitations, you will get the idea. Self-locking property, then efficiency plays important role based on their applications where high and low efficiency is required. High efficiency means more than 50 or 60% and low efficiency is required. That means based on this, you will find the power screws are used for different application. Now let us see first of all high efficiency. The high efficiency, where high efficiency is required in machine tools and presses. In machine tools means suppose lathe machine where the lead screws are used. The lead screws should have a high efficiency compared with the other. Again, second one is the high efficiency because accuracy is important for performing the different operations. Again, low efficiency in screw jack, clamps and vices. Low efficiency. Why low efficiency? Here self-locking property plays the important role. That means application of power screw based on high efficiency or low efficiency. Accordingly, you will find different devices in which power screws are used. Again, here it's okay, the power screws are used, but different forms of threads are used here in case of power screws. Now here forms of threads, you will find generally threads are used for the fastening purposes, and that's why you will find V threads are used for the fastening purposes. But V threads are not suitable for the power screw. Why they are not suitable? Because in fastening, what is the basic requirement? To provide the high frictional force. Why high frictional force? To prevent the loosening of the parts assembled by the threaded joint. But in this case, it is not the case. We have to, here, what we have to do in power transmission, we have to reduce the friction between the screw and the nut. That's why V threads are not suitable for power screws. Try to understand why V threads are not suitable. They are used for the fastening purposes. Then, you will find another form of the threads are available, that is square threads, then trapezoidal threads. These two threads are more suitable in case of power screw. And why these threads are preferred? Because of the power transmission, that is the important thing. Again, you will find here some inversion, you can say the form of trapezoidal thread, that is Acme thread is available. Again, another buttress thread is the another form, but is the combination of square and trapezoidal. I will explain one by one. Let us see square thread. Here you will find the teeth here, the surface which is perpendicular to the axis, The nomenclature is given, you will find in data book also. But what is the main advantages? Again, here you will find how the square threads are going to leak in. Actually, it's a screw, but it's you will find is 90-degree here square threads. Look at this here. Then second one is the trapezoidal thread. Basically, these two threads forms are used in power screw, trapezoidal. Again, here this thread form or thread teeth which is cut with some inclination, angle between these two are 30-degree here. Look at this here. Again here, but some square threads are having some advantage. What are the advantages of square threads? Efficiency of square thread is more than trapezoidal thread. Try to understand. Again, second thing, if it's you will find if whatever the forces which comes on this part, that's why it's a vertical one or straight one which is parallel to the axis, and because of that there is no radial pressure or side thrust which is coming on that. But in this case, in trapezoidal, which is inclined somehow, so you will find there is a problem of thrust or a radial pressure on the thread. Then what is the limitation? The main advantage is efficiency, and second one is the no radial pressure or side thrust on the nut. But what is the limitation or disadvantage of the square thread? The square threads are difficult to manufacture. Why difficult to manufacture? Because to have such a shape of this, the directly straight, only it is possible by using a lathe machine, and by using a single point cutting tool, it will take a lot of time. The manufacturing cost is also more. That's why it's difficult. Then second one is again you will find at the bottom here base. You will find strength of this screw depends upon the thread thickness at the core diameter. The here point, this core diameter or this thickness from the axis, which is less in case of the square, the strength is also is not much stronger than the trapezoidal. Why? I will explain here. So here you will find again it's a straight one. You will find wear of the thread surface is a more serious problem in case of a square thread. The main advantage, efficiency is more. Second one is the no radial pressure, but limitation, manufacturing. Second one is the strength because of this core thickness, and third one is the wear of the thread. But in trapezoidal, look at the another one is the trapezoidal thread. The angle included between this thread, here you will find the 30-degree. That is important, but because of this inclination is having some limitations. But let us see first of all the advantages. So what is the important here? The major advantage. Now because of this here, these threads can be manufactured by using the milling machine. It's multi-tool, the multi-point cutting tools may be used. That means economical to manufacture. Second one, at the core here, at the center of the axis of the nut here, you will find the more thickness at the core. That means because of this more thickness, it's much more stronger than the square thread. This is the second advantage. And third one, in case of lathe machine, you might have seen the split nut. So this to reduce the axial wear of the surface of the nut, it is used in the form of split type of nut, or nut is cut into two parts. This is the another advantage. But what is the limitation? The efficiency of this trapezoidal thread, which is less compared with the square thread. Second one, side thrust. Because of this inclination, there may be possibility of side thrust or radial pressure on the nut. It's another limitations. Again, you will find here the Acme thread. Acme thread is nothing but a special form of trapezoidal thread. Only here inclination or angle you will find here 29-degree. Here Acme threads are shown here. Look at this here. Here in square it's a straight one, but here having some inclination. That angle included is 29-degree. In trapezoidal 30-degree. That means whatever the advantages of trapezoidal and what are the limitations of trapezoidal, which are same as Acme thread. Only difference is in trapezoidal 30-degree inclination, here 29-degree inclination, and they are used for the same applications, that is in machine tools, generally prepared in machine tools and the presses. Then another thread form is the buttress thread. But in buttress thread, you will find it's a combination of square. Square means is a vertical, the one edge here. Look at this one. And second one is the incline. But in Acme and trapezoidal, you find this is inclined with the 30. But in this case, this inclination is the 45 degree. That means combination of square and combination of trapezoidal or Acme, which is made, but angle made here, it is 45 degree. But buttress thread is also having some advantages and some limitation. What is the advantages of this thread? It has a high efficiency than the trapezoidal. It's economical to manufacture. And axial, again here, axial wear can be compensated by using the split type nut. But again you will find here core at the base, which is having the the more thickness, and because of this it's more stronger than the square as well as the trapezoidal thread. But it is having one limitation. What is that limitation? It can transmit power and motion only in one direction. That's why you will find in these buttress threads are used where it is used in vices, where force is applied only one direction toward the workpiece. That is the thing. Look at this, where all these forms of square threads are, or the trapezoidal or Acme threads or buttress threads are used. So you will find the square threads generally prepared in case of screw jack, presses, and clamping devices. Then trapezoidal and Acme threads are used in lead screws and other power transmission devices in machine tools. And buttress threads are prepared in case of vices where the force is applied in only one direction. Try to understand. While designing the screw jack or the clamping devices, you have to prepare square thread. For machine tools or the lead screws, you have to prepare trapezoidal or Acme thread. And for the vices, you have to select the buttress thread. Try to understand. You have to take the care while selecting the form of thread. This is about the form of threads. Another important point here, the single start and multi start screw. So you will find here in some of the cases the threads which are cut in a single on the surface of a rod. But in some of the screws you will find a multi-start screw. Why multi-start screw? Means simultaneously two or more threads are cut side by side around the screw. Two or more threads cut by side around the screw. Why this arrangement is made? Why such a manufacturing or design is made? In some of the application, high traveling speed is required. High traveling speed means large axial motion per revolution of the screw. That means in one revolution, how much is the axial moment of the screw? And if it's a multi-start screw, so you will find you will get a more axial, or you can say it's a lead or axial moment. So that's why instead of single start, multi-start threads are used in some of the applications. It's okay, multi-start screws are having some advantage. What is the advantage? Large axial motion per revolution of the screw compared to with single start. But you will find efficiency is more than single start thread. Why efficiency of multi-starts is more? Because increase in helix angle, because of two or more threads cut side by side, it increases the helix angle, and that's why you will get the more efficiency. But because of this more efficiency, you will find this multi-start threads having limitation. What is the limitation? Mechanical advantages is less than the single starts. The why it's a less? Because more force is required to lift that load. And then second one is because of this efficiency which is more, that means loss of self-locking property. Loss of self-locking property which is required generally in case of screw jack and other devices. These are some of the limitations. So you will find multi-start threads are used in sluice valves or the actuators. Even though you can check the water bottle, you will find here in the water bottle also, you can within half revolution you can open it. That means whether you can check it whether a single start or multi-start. That means to have a more axial motion or the moment within the short, minimum revolution, the multi-start threads are prepared in different applications. Again, designation of the threads. How the threads are designated. Let us the example of your square thread. For a single start, for a square thread, SQ is written, then 30 by 60. What is the 30? Is the nominal diameter. That means to designate square thread, SQ is the nomenclature. Then another one is 30 means nominal diameter is written. Then 6 is the pitch, and this nominal diameter and pitch which is separated by a sign cross, that is multiplication sign. The SQ 30 by 6 means square thread having nominal diameter 30, having pitch 6. And similarly, trapezoidal, how to designate the trapezoidal thread? Trapezoidal thread which is designated here, TR is for trapezoidal. 40 means nominal diameter, 7 is the pitch, TR 40 by 7. But for multi-start, take the example of trapezoidal. Now here it is TR 40 by 14, P7. Consider only this. TR means trapezoidal thread, 40 means nominal diameter. Now here another one important term coming into picture, that is 14, and in bracket P7. P7 means the pitch and this 14 means the lead. The for multi-start, from this lead and the pitch we can easily find out the number of starts. The number of starts is equal to lead upon the pitch. So you will get number of starts 2. So for this multi-start, TR 40 by 14 in bracket P7. 7 is the pitch, 14 is the lead, 40 is the nominal diameter. And in some of the cases, again here another one term which is added at the last, that is LH or RH. LH means left hand thread or right hand thread. Accordingly it is put here. The multi-start threads are designated as TR 40 by 14 means lead, 40 means nominal diameter, P7 means PR, 7 is the pitch, LH or RH, left hand or right hand. It's about the designation of the single starts or multi-starts threads. The another important point before starting, the power screw design in part 2 session I will conduct later on. But before that, you should know some of the terms which are associated with the power screw. Look at this diagram. You will find here, this is the rod over which the threads are cut. All these are the threads are cut. Again here it's you can consider it as a square thread. It's a square thread. Again you will find some of the ear pitch. Generally you already know what do you mean by pitch, but here you will find the points on here. Distance which is measured, pitch which is parallel to the axis. Now let us consider one point on this thread and another point also on the adjacent thread here, corresponding adjacent thread. So you can see is pitch. Pitch means distance which is measured parallel to this axis of the screw from a one point on thread to the corresponding point on this thread. It's a pitch. Then another one is the lead. What do you mean by the lead? When distance measured, again is measured parallel to the axis. But when to measure? When nut advancement in one revolution. That means when it rotates in one revolution. Now take the example. The position of nut is here. When it rotates or when it completes one revolution, you will find half revolution it takes this position and another half it takes this position. This axial movement is known as the lead. That means distance which is made parallel to the axis for a nut advancement in one revolution is known as a lead, which is denoted by small l, p is denoted by p. Then nominal diameter. What do you mean by nominal diameter? Look at this. Is the outer diameter or major diameter. So you can say largest diameter of the screw or major diameter is known as a nominal diameter denoted by small d. Then another term is the core diameter denoted by DC. What do you mean by core diameter? You will find it's a smallest diameter or a minor diameter. Look at this. Smallest diameter. Capital D, outer diameter means major diameter. And there is another term that is DM, mean diameter. Mean D plus DC by 2. So you will get here DM, mean diameter. In between the small d and the DC here you will get the D mean or mean diameter. Another term is the helix angle or the lead angle denoted by alpha. Now here threads. Look at this thread which is cut or thread making angle when one line which is drawn or the plane which is drawn perpendicular to the axis, angle made by the thread which is known as the helix angle or lead angle. The angle made by the helix on the thread, this is thread, and which is with the plane perpendicular to the axis. This is the axis and plane perpendicular means in this way. So you will find this angle made by this, so you will get here this angle is alpha. It is denoted by alpha. These are some of the important terms that we are going to use: pitch, lead, nominal diameter, core diameter, and helix angle or lead angle. The in designation you will find nominal diameter is used. The nominal diameter means largest diameter of the screw. Now let us see lead angle and helix angle. Now in this case you will find, what you will find here in this case, this angle alpha, which is defined as the angle made by the helix of the thread with the plane which is perpendicular to the axis. Now consider this is one of the screw here, development of thread screw. Now here you will find here, look at this, from the center to this, the path which is shown. Now for this purpose you can take one, the thread and round it on the screw, and when this thread is unwound and developed for one complete revolution, so you will find this development from start to up to this. So this is the development here, from this to this. This is the development or hypotenuse of this triangle. It shows the development of this thread here when it is unwound thread. Then second important thing you will find here, the base. Base is the pi dm. Circumference, when it is developed, you will get the pi dm. But when it starts move from this position, when axial moment, in one revolution, the position of the points or the load, or you can whatever the points, in one revolution you will get it achieves this position here. So this distance or vertical distance, that is lead. So what do you mean by lead? Axial moment in one revolution or advancement of the screw in one revolution. That's why this vertical distance is L. Base is the pi dm, and this inclined surface is nothing but a development of this unwound thread. So we have to use this triangle for further our analysis. And when you are going to observe the top view, you will find here, again here, the outer diameter is the D, inside diameter is the DC, then dm is the mid diameter. So you will find, so what we are going to use, how we are going to use this, the diagram or development of thread. So to raise the load or to lower the load, we are going to consider this hypotenuse is a thread on which how the load is going to move. When it moves toward this side, we are going to say it's a lifting or raising of the load, and when it goes down along this hypotenuse, we are going to say it's lowering the load. But to raise or this lower the load, we have to apply the effort. This effort, that is the P, which is acting at the dm, and it should be perpendicular, or its position always perpendicular to the load, because load it acts vertically downward, and P, which is perpendicular to this, the P effort which is required, which acts at a dm, and which is required to raise or lower the load. From this, by using fundamentals in this session, we are going to see how much is the torque required to raise or torque required to lower the load. So before that, so we have a nomenclature here. This is the pitch. Again here, the depth. In case of the square thread, what is the depth of this thread? P by 2. Again, this distance is also P by 2, and this is the pitch P from this point to corresponding points on the thread, and this is measured along the axis. Referring to the square thread, look at this. So you will find what is DC. So you will get DC is equal to D, nominal diameter, minus P by 2 plus P by 2. So look at this here. This DC, D minus, here how much is the P by 2, and this side also P by 2. So that's why DC is equal to D minus P by 2 plus P by 2. But when we are going to add to this P, you will get 2P by 2. 2 gets cancelled. So you will get DC is equal to D minus P. Then what do you mean by dm? I have already told how to calculate this dm. dm means D plus DC by 2. dm outer is the D, inside is the DC, and at the middle we have to take the average 1 by or 1/2 D plus DC. But what is the DC? We have already calculated D minus P. We can go into substitute here. DC. So what you will get dm? dm is equal to 1/2 D plus in bracket D minus P bracket complete. The D plus D, 2D by 2, so you will get D, and P by 2, so 0.5. So you will get dm is equal to D minus 0.5 UP. Try to understand. You have to remember this equation is very important. In many times while solving the problem, we have to find out the dm also. Again, this equation is also important. DC is equal to D minus P. Then from this, the when the thread is unwound from the screw here, you will find this hypotenuse is the developed form of the thread. By referring to this triangle, base pi dm and the axial lead is the axial moment. By referring to this triangle, you will get this alpha or lead angle over the alpha or tan alpha is equal to L upon this pi dm. That means by using this expression of this alpha or helix angle, we can easily find out the lead. For that purpose, or by using this expression also, you will get the alpha angle once you know the lead. Again here, in single start and multi-start threads, the important point for the single start thread, the lead is equal to, I have written here, look at this, single start thread lead is equal to the pitch. But multi-start thread lead is equal to Z into pitch. Z means number of starts. The here what you have to take into account, when it's a 2 starts, that time lead becomes 2 into pitch. When it's a 3 starts, lead becomes 3 into pitch. For single starts, lead is equal to pitch. So we can substitute here based on the pitch. Then pi dm, here you will get the dm from this. By using this, the relations, we can easily find out tan alpha or alpha. It's here this angle, helix angle or a lead angle. And again further we can use this alpha for further to find out the the efficiency of the power screw also. This is about the importance of the lead angle. Again second thing, this lead angle alpha depends on the lead and the dm. These are the importance of lead and the mean diameter. From this relation you will get the idea about it. Then next, based on that, torque required to, there are two cases. First case is torque required to lift the load. In screw jack, suppose to lift something to give the supports here, how much is the torque required to lift the load? Again second thing, we have already told that it's having a more, the more mechanical advantage. That means by putting less efforts, we are using the more capacity load. So how to find out the torque required to lift the load and torque required to lower the load? So here you will find this P is the effort which is perpendicular to the load that we have to put, and that the effort means force, then dm by 2, so you will get the torque here. This is the torque required that we have to find out. But what is the value of P, we will see in this expression. Now let us consider here, by using the same triangle already explained here, when the threads are unwound, this is the thread, then this is the base, and this is the axial moment is the lead. The same triangle we are going to use. Look at this. Base is the pi dm, L is the lead, and this is the inclined plane is nothing but a screw. Inclined plane is nothing screw. Torque required to lift the load means from this position up to this position in one revolution, that is the lead you will get. How we are going to lift it? To lift it, what some of the forces are going to act on it. Now let W is the load which is to be lifted, and always W which is to be lifted, you will find it acts vertically downward direction. So that's why in this figure it showed downward direction. Then alpha, helix angle. Then you will find the P towards right hand side. What is this P? Is the effort required to lift the load, and always is acts perpendicular to the W, perpendicular. But its direction, whether towards the left hand side or towards the right hand side, that we have to decide. Now here the case is torque required to lift the load. That's why it's to lift means toward this side. That's why P is towards right hand side. Then here N is the normal reaction. The normal reaction means because of this load, normal reaction which is perpendicular to the inclined place. Already you studied in applied mechanics and strength of machine element. Normal reaction. But when this load which moves vertically upward direction, there is another, the mu1 is the frictional force which acts opposite to the direction of the motion, because this, the load which is moving towards upward direction, the frictional force mu1 which acts towards the downward direction. Always you are aware of that. So all these are the forces which are acting. One W is the vertical load, P is the effort towards the right hand side, then N is the normal reaction perpendicular to the inclined surface, and mu1 is the frictional force opposite to the motion. By considering all these forces, what we have to do? We have to find out the equilibrium of vertical, equilibrium of horizontal, to find out how much is the torque required to lift the load. Let us see. Equilibrium of horizontal forces. Now this P is horizontal, the P is equal to, now mu n is having some inclination, this angle is alpha, that means this angle is also the alpha. So what you will get? Mu n cos alpha, this component, adjacent side, the mu n cos alpha plus, why it is written up equal to? Because it's opposite, plus, now here look at this n, which is perpendicular to inclined phase. So what we have to do? We have to find out this sine. You will get the sine components here, the n sine alpha. The equilibrium of horizontal forces, you will get mu n cos alpha plus n sine alpha, equation number 1. Then equilibrium of vertical forces, in vertical W, the W is equal to, so what you will get again here? N cos alpha. Look at this towards this side, adjacent side, n cos alpha minus again this. So what we have to do? Again here, if you are going to draw one line, you will get this component. So here you will get the minus, because towards this side, the minus mu n sine alpha. So you will get to equation 1 and equation 2 for equilibrium of horizontal forces and vertical forces. And dividing this P by W here, divide P by W. The P by W you will get mu n cos alpha plus n sine alpha upon n cos alpha minus mu n sine alpha. Send this W towards this side, so you will get P is equal to W in bracket mu cos alpha plus sine alpha upon cos alpha minus mu sine alpha. Again dividing numerator and denominator by cos alpha. The here you can divide here. So what you will get? P is equal to W in bracket mu cos alpha निकल जाएगा. You will find here mu plus and sin alpha upon cos, it becomes tan alpha upon here. What you will get here? Cos alpha by cos means 1 and mu sin alpha by cos means mu tan alpha. So you will get this expression here. Then further, but we know that mu is equal to tan pi. Already you studied in friction. The mu is equal to tan pi. Here, what is pi? Pi is the friction angle and mu is the coefficient of friction. So substitute this value mu is equal to tan pi. So what you will get here? This equation you will get P is equal to W and mu is replaced by tan pi plus tan alpha upon 1 minus mu means tan pi, again tan pi plus tan alpha. This is where pi is the friction angle. So again this is the the geometrical relation or formula already you studied in 11th or 10th standards. So you will get P is equal to W tan, the tan plus tan pi plus tan alpha upon 1 minus tan pi into tan alpha is equal nothing but a tan of pi plus alpha. So substituting this you will get P is equal to W tan of pi plus alpha. So what we have to do? We have to find out the torque required to lift the load. So what is the torque? That is MT. MT means P, that is support required which acts perpendicular to the W. P into dm by 2 is the mean radius. So what we have to do? What is the P? Already calculated this value, or this value you can substitute here. So what you will get? MT is equal to W tan of pi plus alpha into dm by 2. So this is the torque required, which is shown in highlighted bracket, to lift the load. By using this equation we can easily find out how much is the torque required to lift the load in case of the power screw, and it is applicable. In this case we have considered this square thread. Try to understand. If you are going to consider the Acme or a other thread, trapezoidal thread, that time because of the inclination angle included 29 or 30 degree, the equations are going to change. These equations are applicable to square thread form. Then another case, it's a simple one, torque required to lower the load. So you will find lower the load means from this position, this thread towards this side. Again here, based on this, the nomenclature which is remains same, only the position of the forces which are acting on this inclined surface are going to change. So you will find N is the normal reaction perpendicular to the inclined plane, W is the load, always it acts vertically downward direction. But here when it moves, because torque required to lower the load means towards this side, that means frictional force is acts opposite to the motion, that's why it acts towards the this direction, that is mu1, and P is the effort, because which is towards the left hand side. Why left hand side now? Because we are lowering the load, that's why. Again, the same method that we have to use, already used in earlier, the slide, that is torque required to raise the load. So what we have to do, equilibrium of the horizontal forces. The horizontal P is equal to, again here you will get the cos component of mu n, so you will get P is equal to mu n cos alpha, and again for the sine component of n, that is n sine alpha. Then equilibrium of vertical forces. Vertical means W. W is equal to n, again here you will get n cos alpha, plus again here this component you have to take into mu n sine alpha. Again what you have to do, divide P by W, like the same procedure that we have to follow. So doing this and sending W towards, you will get W is equal to mu cos alpha minus sine alpha, cos alpha plus mu sine alpha, and dividing numerator and denominator by cos alpha. So what you will get, P is equal to W mu tan alpha, mu minus tan alpha upon 1 plus mu tan alpha. Again what we have to do, but we know that mu is equal to tan pi, pi is the friction angle. Substitute here, mu means tan pi. So what you will get, P is equal to W tan pi minus tan alpha upon 1 plus tan pi into tan alpha. So you will get this expression. But again, tan pi minus tan alpha upon 1 plus tan pi into tan theta is nothing but mathematically tan of pi minus alpha. So we are going to substitute here tan pi minus alpha. So what you will get, P is equal to W tan of pi minus alpha. And again torque required to lower the load, P into dm by 2. To substitute this P, W tan of pi minus alpha into dm by 2. So you will get, this is the torque required to lower the load. These are the two cases, torque required to raise and torque required to or lift or lower the load or lowering the load. Now let us see the important things, that is the concept of self-locking, because in case of power screw or screw jacks or the other devices, you will find self-locking plays an important role. And how to achieve it, we have many times the applications of the power screw based on the high efficiency requirement or low efficiency, but you will get the self-locking at the lower efficiency. We will see when we are going to derive the expression for efficiency of the power screw. So before that, let us see what do you mean by self-locking and the concept of this self-locking. So you will find here in torque required to lower the load, the MT is equal to W dm by 2 tan of pi minus alpha. I have written the same equation. This is the torque required to lower the load. But look at this, pi is the friction angle, alpha is the helix or the lead angle. When pi is less than alpha, so you will get this term becomes the negative one, or torque becomes negative. When it becomes negative, that means no force is required to lower the load. So what is going to happen during that times, load itself begin to down, and this condition known as overhauling of the screw or back driving. That means without applying the effort directly, the screw which is going down, that means back driving, or itself begin to down towards downward direction. This is known as the overhauling of the screw or back driving of the screw. Generally such a situation or such a case which is used in Yankee screwdriver. Yankee screwdriver, you will find the different screws or tools, the screwdrivers are available, and when it's inserted and rotated towards the opposite direction, then you can use it for the different purposes. So this is the case, or negative torque. Because of this negative torque, no need to apply the effort to the load itself begin to down in case of overhauling case. But now take the, when this pi is greater or equal to alpha, pi is the friction angle. So that time what is going to happen, if pi is greater than the alpha, you will get the positive term. The MT is also positive. The positive torque is required to lower the load. Positive torque is required to lower the load. That means load will not turn itself or turn screw without effort. That means screw does not descend on its own towards downward direction. That means it's a condition of self-locking. That means to lower the load, effort is required. Without effort, screw does not descend on its own towards downward direction. This condition is known as self-locking of the screw, and generally you will find this self-locking condition which is very useful in case of screw jack. While designing, self-locking is the important thing. Try to understand this concept is very important, and that's why pi should be greater than alpha in case of screw jack or self-locking condition which is you try to understand. So you will get idea from torque required to lower the load, pi if less than alpha, it's a overwhelming condition, and if pi, that is friction angle, is greater than the lead or the helix angle, this is the which case? Self-locking case. But you will find what is pi. So you can here is tan pi is equal to tan alpha. Both the side tan of pi and tan of alpha. So what you will get? Tan of pi is nothing but a mu, and here you will get the tan alpha. So mu should be greater than equal to tangent of helix angle. This is the another case. You can say for self-locking, coefficient of friction should be greater than or equal to the tangent of this alpha. And again, what is the mu? So tan of here mu is greater than, we know the tan alpha already, we have derived this expression, tan alpha is equal to L upon pi dm. That means coefficient of friction should be, that means self-locking property depends on the mu, self-locking property depends on L, and self-locking property depends on dm. That mu, L, dm are the important, along with this pi and the alpha, along with this pi and the alpha. Try to understand here. So what we are going to say here in this case, in self-locking, to have a proper, the self-locking property of the screw, if this mu is less, what is going to happen? When coefficient of friction is low, what does it mean? It means screw is going to lose. Self-locking property is not possible when the mu is less. And when you will get the mu is less? When there is a excessive, the lubrication in case of screw and the nut, it loses that property. This is one thing, important thing. That means the value of mu should be high to have a self-locking property. Then second one, when lead, now in this case, mu is greater than this L. L is the lead. But when lead becomes large, that time also screw is going to lose self-locking property. It should be less here. But when it becomes large, the self-locking property, screw is going to lose self-locking property. And with the L is large, when you are going to use a multi-start state. In multi-start state, in single revolution, you will get the maximum axial moment. That means to have a self-locking, to use single start states. If you are going to use a multi-start state, you will get the value of L is a more or higher value. And if it becomes a large, then this mu, the screw is going to lose a self-locking property. Try to understand. That means the what care we have to take, the L should be within the limit and mu should be low to have a self-locking of the screw, or other case friction angle should be greater than the lead angle or helix angle, or mu should be greater or equal to the tan. All these are the conditions for the self-locking. This is about the concept of self-locking to prevent its movement towards the downward direction. Recap or some questions. Based on this session, I have already explained some of the the questions. Even though you have some again recap of the today's session. What are the advantages of power screws? State some application. What are the advantages? Mechanical advantage, simple, economical, manufacturing cost, compact one, all these are the advantages. You can write it, no problem. Then some applications, screw jack, C-clamp, then vices, then puncture machine, then many applications you can write. Then what is the self-locking of the power screw? Self-locking means to prevent its movement towards the downward direction, it's one. For that purpose, different conditions are used. What are the different conditions of self? Pi should be greater than alpha, mu should be greater or equal to tan alpha, mu should be greater than L upon pi dm. These are the conditions for the self-locking. You can explain it. What are the disadvantages of square thread? So what is the disadvantages? The manufacturing is complicated or difficult one, because single point cutting tool is used in lathe machine to manufacture, that the cost is also more. That's why it's not economical. And second one is the wear associated because of the this thread which is directly perpendicular to the axis. That's why wear is the another major concern. Then what are the advantages and limitation of multi-start state? So what is the advantage of multi-start states? You will get the axial moment with less revolution. This is the advantage. But what is the limitation? Efficiency. You will get the high efficiency because of this multi-starts. The helix angle is going to increase here in this case. What you will get the maximum efficiency, but limitation because of that maximum efficiency in screw, it loses its self-locking property. That is the limitation. Try to understand. This is about the some of the the questions already I have already discussed during this session, but you should know. If you have any question, you can contact me at 9890426679 or mail me at pvkoshar@kkvak.edu.in. Thank you. I have referred here Vivi Bandari's book Design of Machine Element, 3rd edition, McGraw-Hill publication.